All right, welcome back to day 4 of 4 on our unit on climate. Today we're going to talk about the greenhouse effect and climate change. These two things are related, but they are completely different. Okay, so day 4 of 4. Today you will know how carbon circulates through our Earth, the carbon cycle. You will know what the greenhouse effect is and how humans are altering this natural process. Okay, you will know what global warming is and its consequences. Okay, so get that down, your topic in your unit, and here we go. So for your quick write, do you believe the climate is changing? Why or why not? And why do you think big business and other people are reluctant to accept the theory of global warming? Okay. All right. So that's your quick write. Hopefully you have heard of climate change here. So go ahead and pause this while you do your quick write. We're going to move on. Okay. So the carbon cycle. The carbon cycle is the movement and circulation of carbon throughout the earth, air, ground, and life in the form of carbon dioxide, CO2, in the air, carbohydrates like sugars that you eat, and in life, and then we have fossil fuels in the earth, pure carbon basically. Okay. Well, carbon comes in many forms as it circulates through our earth. Okay. Carbons come in life in the form of carbohydrates, C6H12O6. Okay, that's the simplest of all carbohydrates, so C6H12O6. So carbon is in life, right? Carbon is in the air in the form of CO2, carbon dioxide. Okay, CO2. Pure carbon is also in the ground in the form of rock, coal, and oil, fossil fuels, down here. Okay, so in fossil fuels. Carbon can change form, though, from these different types I just mentioned. Plants and trees take in CO2 through photosynthesis, and it is converted into oxygen, which is nice for us because we like oxygen, and carbohydrates. So plants produce carbohydrates. They're life, right? So they take in CO2 and they create, a carbohydrate. Okay. Well, over time, plants and animals die, becoming fossil fuels, which are basically carbon stored underground, coal and oil. Okay, pure carbon essentially. Oil is essentially almost pure carbon and hydrogen. Okay, so, well, the burning of trees and fossil fuels release CO2 back into the atmosphere. Well, the burning of trees is a natural process for the most part. Okay. But the other process, by burning fossil fuels is not. So we are releasing fossil fuels, which is therefore releasing CO2. Okay, more CO2 than we like, unfortunately. So today the carbon cycle is out of balance due to the burning of trees, which remove carbon or CO2 from the air. Moreover, cars and factories burn these fossil fuels, which release a tremendous amount of carbon dioxide, CO2, back into our atmosphere. Okay, so the carbon cycle today is out of balance. Okay, we have a tremendous amount of CO2 being put back in the air through methane and CO2. Okay, through the burning of fossil fuels mostly. Okay, so what is the carbon cycle? Long one for your notes. Question on the left-hand side, answer on the right-hand side, please. Always use the answer bank here to determine which words best complete the sentence. Go ahead and pause this while you write. I'm going to move on. Okay, so the greenhouse effect. The greenhouse effect is a natural heating caused by gases in our atmosphere trapping or absorbing heat. Okay, it's natural. It's been going on for millions of years. The planet Venus has a very severe greenhouse effect. But we have a greenhouse effect as well. Okay, gases like carbon dioxide here, water, vapor, and methane are the main greenhouse gases that absorb a lot of the sun's heat. Okay, so like I said, Venus has a major greenhouse effect because its atmosphere is made almost entirely of carbon dioxide, CO2. The greenhouse effect is similar to what's happening on your car on a hot summer day. It gets really hot in the inside when you open the door. Okay, it's kind of trapping the heat here. So let's examine this a little further. The greenhouse effect here. Okay, solar energy from the sun, okay, short wavelength radiation passes through the atmosphere and warms the earth. So sunlight, basically, a lot of the sunlight passes through our atmosphere and warms the earth, okay? Well, the Earth's surface radiates heat, okay, back into our atmosphere in the form of long wavelength heat waves, okay? Some heat escapes, okay, which is good. So about 1% of Earth's atmosphere is made up of greenhouse gases, CO2, methane, and water vapor, okay? And these gases absorb the heat, okay? Like I said, these greenhouse gases, CO2, methane, and water vapor, absorb or trap this heat, keeping our atmosphere warm, which is good. It's been keeping us warm for millions of years. Okay. However, as we humans add more of these greenhouse gases, CO2, methane, and water vapor to our atmosphere, okay, we are trapping and absorbing more heat, and therefore altering our climate, okay, and changing the greenhouse effect. Okay. So our atmosphere and climates are steadily warming. Okay, so for your notes, what is the greenhouse effect? Question on the left-hand side. Answer on the right-hand side. Okay, use the answer bank to determine which words best complete the sentence. Go ahead and pause this while you write. I'm going to move on. Okay, so evidence for a warming world. And scientists tell you that the Earth is warming, well, where's all that evidence coming from? The strongest evidence comes from ice cores that have been drilled throughout Greenland and Antarctica. The ice on these continents are thousands of years old and contain bubbles with thousand-year-old air. Okay, like I said, this very old ice contains bubbles of very old air. Okay, so we have these ice cores from drilling down into the ice sheets. So let's look at this layer of ice here. Let's say the top represents present day, and down here represents 800,000-year-old ice. So below is a glacier that contains layers of ice dating back thousands of years. Scientists drill down and remove these ice cores from these 800,000-year-old glaciers. Okay, they drill down and remove these ice cores. Okay, so they take a slice of these ice cores, like this 400,000-year-old ice contains 400,000-year-old bubbles of air from 400,000 years ago. So 400,000-year-old ice was analyzed by scientists, and we looked at these bubbles. Okay, scientists analyzed thousands of ancient air samples, from present-day samples to 800,000-year-old samples. Okay, so by analyzing ancient samples of air, we can determine what our atmosphere was like during periods of ice ages and periods in between ice ages. We call these interglacial periods. Okay, so one thing scientists measured was the amount of or concentration of CO2 inside the ancient air bubbles. When scientists compared the amount of CO2 in the bubbles to the Earth's average temperature at that time, a remarkable connection between the two was made. Okay, so going back 800,000 years ago, here's the average global temperature, here is CO2 concentration. So let's overlap these graphs and see what happens here. Okay, do you notice a similarity by any chance? Okay, so CO2 concentration and the average global temperatures. Okay, pretty close. And here is our current level of CO2. So you could probably expect a trend to increase here. So the average global temperature will most likely follow this CO2 concentration trend. Okay, so for your notes, what are ice cores? Question on the left-hand side, answer on the right-hand side. Go ahead and pause this. I'm going to move on. While you write, go ahead and pause this. Okay, so the last thing we're going to talk about today in climate is global warming. Simply put, global warming means global temperature rising, right? So one reason for global warming is the increase in greenhouse gases in our atmosphere. If the average temperature continues to rise, okay, things like ice caps will continue to melt, low-lying areas will experience flooding. The ice caps are already beginning to break apart, causing a rise in sea level. Okay, Here's this famous, it's called the hockey puck graph. This is, okay, data, okay, from the Earth's past average temperature. And here's what we see, okay, the average temperature of the Earth steadily rising here just in the last 1,000 years from ice cores and all sorts of data, okay? So, look at this graph in the CO2 emissions. The greenhouse gas, CO2, is the main gas responsible for climate change or warming the Earth. Which country here is the big, since 2002, it's changed since then. We're not as bad as we were, but since 2002, which country is the main contributor of greenhouse gases? Okay, we got USA, USSR, China, EU, Japan, India, and Canada. Okay, so do a little comparison on your own. Okay. So here's what an 8-foot rise in sea level would look like. Okay, much of the southeast coast would be underwater. Just an 8 feet rise in sea level. And this is a graph showing the current trend in sea level rise. Okay. Here's Mount Kilimanjaro, which normally had glaciers on it in 1976, the year I was born. And look at Mount Kilimanjaro now in 2006. Okay, all those glaciers are gone. Okay, they're rapidly receding. Look at these glaciers, the Peterson Glacier here. In 1920, this was all full of ice. In 2005, it is gone. Okay, the Muir and the Riggs glaciers. This whole glacial area is now just a lake. Okay, so you can see these glaciers beginning to melt. Here's the northern ice cap. Here's the northern ice cap line in 1979, this red line. Okay, 20% of that ice cap has now melted. And here's what it is today, even worse than it is today, actually, than this, since this diagram was made. So it's even melted even more. Okay, so you can see the comparison of the ice caps. And these are taken both in the summertime. Okay. So what if the theory of global warming isn't true and skeptics are right? What if the Earth's climate isn't changing? Okay, well, consider all the evidence I've presented before you, but consider this. Okay, if the theory of climate change isn't happening, what's the worst that could happen? We clean our air, okay, we clean our water, we create more jobs, okay, high-tech energy jobs, jobs of the future, and we no longer see massive damage to our environment like oil spills and potential loss of life. Okay, so the last one for today is, what is global warming? Okay, and make sure you write down the effects here. Okay, so question on the left hand side, answer on the right hand side. Go ahead and pause this while you do the last one, day of climate, for your notes. Okay, go ahead and pause this while you write and summarize here. How is the carbon cycle out of balance? What is the main gas responsible for climate change and global warming? Describe the greenhouse effect in your own words. What are some consequences of climate change and global warming? What have ice cores revealed about past climates? Okay, so go ahead and pause this, complete the summary for 20 points, and you're all finished with your climate notes. We'll see you next time.